So hello everyone. Again, welcome to one of the videos in Aptitude series. Today we'll be discussing a very important topic, which is called permutation and combinations. And I think most of the students are really uncomfortable in this topic. So this topic is very simple, but it is made very complex when this is taught. Okay. So what we'll be doing is we'll be covering just few basic concepts which are there, and once we complete that, then we'll see different type of variations which are present in the question. Okay, and once we cover the variations and understand how those concepts can be modified little bit and applied in different manners in the questions, then we'll see all the gate questions which are there, okay, based on this. So this video will be actually this topic in fact will be covered in two parts. One will be your concept coverage and seeing different variations in the question, and the second part of the video will be only for previous year gate questions. Okay, so this video contains all the basics and the variations of how those basics can be used. Next video will contain the gate questions. All right. Okay. So my name is Karthik Kharbanda and I am associated with IGC team. I did my MTech from IIC Bangalore. All right. Okay. So this is the outline for the video for the both the videos combined. Okay. So these four things will cover in the video one, and this thing will cover in video two. Okay. So video two has all the previous year gate questions on PNC. All right. Okay. So now in permutation and combination, there are, I'll say in briefly, there are two methods by which you can solve every problem. Okay. The first method is known as selection and arrangement method. All right. And the second one is known as fundamental counting principle. Okay. Fundamental counting principle method. Right. So we'll see what kind of these methods, what these methods are, and how they actually help us solve the problems. Okay. So if I discuss about method one, that is selection and arrangement method, the questions which fall into this, okay, so one more important thing, these two methods both of them can solve a particular problem, okay? But remember, if you have a particular problem, one method might prove difficult to, use when you are solving it, and one might prove easy, okay? So depending on which method is easy, you will have to choose which has to be applied in a particular problem. So I will say trying to understand both the methods is equally important. Okay, do not focus only on one method, and should not be like your other method is you are weak in applying the other method. Okay, so just make sure this thing is maintained throughout the PNC video. Okay, so now I'll talk about selection and arrangement method. So in this method, the first thing that we have to do is we have three subcategories of questions. Okay, let me call this as type 1, type 2, and type 3. All these three categories fall in selection and arrangement method. All right. So type 1 is selection only questions. Okay. Type 2 is arrangement only questions. And type 3 is what? Selection and arrangement questions. All right. So type 1 is selection only, type 2 is arrangement only, and type 3 is selection and arrangement. Okay. So whenever you see a question and you decide, okay, I'll be choosing this method to solve the problem, your first task is to identify out of these three categories, the problem is lying in which category. Okay. Once you identify that, you will know, okay, do I have to do selection, do I have to do arrangement, or do I have to do both of them? Okay, that is very vital and very important. Okay, all right. So once we are able to identify, now let's see what exactly I mean by selection and what exactly I mean by arrangement. Okay, so see, it is as simple as that. If I say something which is NCR, this means select R things out of a total of, okay, so you have n things, out of that you have selected R things. Okay, okay, select R things out of total of n things, and NCR gives you number of ways of doing that. Okay, this basically gives you number of ways of doing this in which this can be done. Okay, so basically number of ways in which I can select R things from n things. Okay, now if you remember, the formula for NCR is n factorial by R factorial into n minus R factorial. All right, this is the formula. All right, now many students try to use this thing also, which is NPR. Okay, my advice is I usually don't do this, use this to solve problems. Okay, because it creates little confusion, and I'll tell you what the confusion is. Okay, so when you're doing NPR, that means number of ways in which I can select and arrange R things out of n. Okay, so basically NPR, what it does is it does the selection and arrangement in a combined manner. Okay, and the problem over here is if I don't apply condition constraint on selection, but I apply constraint on arrangement, that cannot be done using just NPR. Okay, you'll have to do something more. So that's why what I follow is I try to separate out selection and arrangement, do them separately, and then write my answer. Okay, that's the thing that I like to follow, which makes the understanding for the solution. If let's say you're trying to solve a problem, you're not able to get the solution, and you read something, so you will be able to understand the solution in a much better way as compared to if I just write NPR. Okay, so I try to follow this category, you can say strategy, where I don't use NPR. Okay, I try to write it in terms of NCR only. Okay, we'll see that how that's done. We'll see later. Okay, so this is, now we'll see, now NCR and NPR story is clear. We'll see how to categorize a question in type 1, 3. Okay, just remember these are the types, and then we'll see some questions in which you will have to choose which category this question belongs to. Okay, so the first question is, in how many ways can a group of in how many ways can a group of 5 students be made out of a total of 10 students? Okay, so you have 10 students, you have to just make a group of 5 students. Okay, so try to, this question belongs to which category? Okay, I think you were able to identify that this question, I just need to select 5 students out of 10 and make a group. Okay, so the order over here or the arrangement, really I don't really care about the arrangement, so this is a selection only category. Okay, this question belongs to selection only category. So when you do selection only, selection means NCR. Okay, so all you have to do is select 5 students out of 10, and that selection or a group formed of 5 students can be done in these many ways. Okay, so in these many ways you can form a group of 5 students out of a total of 10. All right, a group of 5 students out of a total of 10. All right, okay, so this was only selection only question. All right, so next thing, let's see, this is the question. Make 10 students sit on 6 chairs, assuming one student occupy only one chair. make 10 students sit on 6 chairs, assuming one student occupy only one chair. All right. So now see, the problem is you have more number of students, you have less number of chairs. That means, and assuming that only one student occupies single chair, you cannot really make 10 students sit on 6 chairs, right? So what you have to do is, always 6 students can sit on 6 chairs, even 7 students cannot sit on 6 chairs. Okay, so that means 4 students will remain, 4 students will not be able to sit on the chairs, right? They will stand, right? So what we do is, first we try to identify, this question is what, selection, arrangement, or selection plus arrangement. Okay, so understand this. First you have to select 6 students now out of those 10, and then you have to make them sit on chairs. Okay, so if you were able to identify, this question is selection plus arrangement, both, type 3. Okay, selection plus arrangement category, type 3. Okay, so now we'll see how to do selection and arrangement both. Okay, selection and arrangement, let me say. So now 10 students have to sit on 6 chairs. Now all 10 cannot sit. So what I have to do is, first I have to see the number of ways in which I can select 6 students out of 10. So that can be done in 6C10. 10C6, sorry, 10C6. Okay, that can be done in 10C6. Now your job is what? Now you have, see, after this thing, now you have 6 students with you. Okay, number of ways in which 6 students can be selected out of 10 is 10C6. Now you have 6 students. Okay, and each of those, see, these are number of ways in which you can select 6 students, right? And each of those 6 students, the selected 6 students, all of them can sit on chairs, right? So all you do is, you have 6 chairs with you. Okay, follow the strategy. So how many choices are there for the, for the first chair? How many students can sit on first chair? On first chair, any 6 students can sit, right? Any 6. Now one student will occupy out of those 6, and for the second chair, now only 5 choices are there, right? Similarly, for the third chair, only 4 choices: 3, 2, and 1. And these things are multiplied together. So that means 6 students want to sit on 6 chairs. How many ways that can be, that arrangement can be completed? It is what? 6 factorial. Okay, so 10C6 into 6 factorial becomes your answer. Okay, so this guy was the selection part, and this guy was the arrangement. Right, so I hope this thing is clear to everyone. Category, you have to identify which this question belongs to which category. All right, okay. Fine. So this is just a variation now. Okay, so we'll see that question later. Now you understood the first part where I'm talking about selection only and arrangement only. Okay, let me just give you a question, okay, to explain what questions fall in type 2. Okay, so let's say the question was simple. Make 5 students sit on 5 chairs. Okay, assuming one student sit on one chair. Now how many ways can this be done? Okay, now the thing is that you have to make 5 students sit on 5 chairs. How many ways can this be done? Now see, you'll again think, okay, let me think of applying uh, selection and arrangement method. Okay, so first is this a selection question? No, because you have to make them sit. So arrangement matters over here. The order in which the students will sit matters. Okay, so arrangement is definitely there. The question is whether selection is required or not. See, selection will be required if we have more number of students or we have more number of chairs. Since we have equal number of students and equal number of chairs, all you're required is what? You have to just arrange them. So this question falls into the category of type 2. Okay, fall into the category of type 2. And now what you can do is, now you can try and make them sit on 5 chairs. So just place 5 chairs, and first guy can sit on what? On first chair, 5 any 5 people can sit. one person will occupy this chair. On the second chair, now remaining four, anyone from remaining four can sit. Okay, with 3, 2, and 1. So how many ways are there in which this task can be performed? Total 5 factorial, or this will be 120 ways. Okay, 120 ways. So this is an example where you are not really required to select. You are only told to arrange. So we'll only worry about arrangement. All right. So this is how you do selection and arrangement type of questions, or you do questions using selection and arrangement category, and this is how you use it. Okay. Okay. So now what we'll do is now we'll understand fundamental counting principle. Okay. How do we solve that? So remember one thing. When I talk about fundamental principle counting method, now this thing takes care of selection, arrangement, both of them internally. Okay. Takes care of selection and arrangement internally. We'll see how. Okay, you'll not have to explicitly select and then explicitly arrange. That won't be required. Okay. So see, if I solve this question using fundamental counting principle, so what you do is whichever is less. Okay, if they are equal, you can choose any one. Whichever is less, you try to choose that. Okay. So I have 6 chairs. I have 10 students. So what I'll do is I'll select 6 chairs now. 2, 3, 4, 5, 6. I have 6 chairs with me. All right. Now what I'll do is instead of previously what we did was we selected 6 students out of 10 and then made them sit on 6 chairs. Now I'll not select anyone. Okay. I'll not do the selection. I'll directly make them sit on the chairs. Okay. So now for the first chair, any 10 students can sit. Correct. Right. Any 10 students can sit. For the second chair, any 9 can sit because one will occupy the first chair. Similarly, for the third chair, 8, 7, 6, and 5. Okay. So if I ask you how many ways can this be done, this will be nothing but 10 into 9 into 8 into 7, 6, and 5. So this will be the answer. Whatever this evaluates to, this will be your answer. Okay. So these are the number of ways in which 10 students can sit on 6 chairs using fundamental counting principle. Right. Directly we did it. So if you see, this took care of selection and arrangement internally. Okay. Because now 4 students will always remain standing because there are only 6 chairs. All right. So I hope this was clear to all of you. Right. So now, okay. Now what I'm trying to do is we'll keep our basic question same, that is 10 students sitting on 6 chairs, but I'll keep adding constraint to it. Okay. And this is how a PNC question is formed. Okay. When any faculty or examiner is trying to make a PNC question, this is how they do it. Okay. So we'll keep on adding constraint to our basic problem. So the basic problem is 10 students sit on 6 chairs. Okay. Now I'm saying particular one student is always seated. Particular one student is always seated. Now, what I'll say is, it is up to you which method you want to choose. Okay, you can choose method 1, you can choose method 2, but I will show only one method which I feel is comfortable to me and which I feel is the easier one for the given problem. Okay. But when you're practicing, I'll advise you to think using both methods before, because I told you you need to master both the methods so that whichever whatever kind of question comes in exam, you are able to correctly apply the right method and get answer in a easier fashion. Right? Okay, so such that one particular student is always seated. One particular student is always seated. See, I have 10 students, let's say S1, S2, S3, and up to S10. Okay. Imagine he's the boss of the class. Okay. He's the boss of the class. Okay. Boss of all 10 students. I mean, if he'll say something, that has to be done. Okay. Rest all students are like friends with this boss and he's the boss guy. Okay. So let's say this is the boss. Fine. Now what I want is the boss should always be seated. It should not be like boss is standing. So in the selection thing, now I have a constraint, and the constraint is I need to make sure that boss is always selected for the chairs. Okay. There is no way in which I will not select boss. Okay. So I'll say, okay, you are always selected. Always selected. Okay, always. Now, see, one person is always selected for the chairs. Now, remaining out of remaining 9 persons, I have to select what? 5 people, because 1 plus 5 will give me 6 people, and then I can arrange them on the chairs. Okay. So out of those 9 people, now I have to select 5 more so that I have a total count of 6. And since this guy is always selected, I have to just find number of ways in which I can select 5 more. Okay. So let's say this is what, 9C5. All right, 9C5. And then this is the selection part. And then now you have to arrange. See, arrangement, I did not put any constraint because I'm saying just arrange them in 6 chairs. Okay, that we have already seen can be done in 6 factorial ways. Okay, the boss is saying I need to sit, okay, every time. It doesn't matter where you place me, but I need one seat for myself. Okay, so how many ways can this be done? Okay, 9C5 into 6 factorial. Okay, so I hope this variation of the question was clear. Let's try another variation. Okay. Now what I'll do is I'll tell you to pause, since now you're familiar with the methods and with the type of variations you have. Now try to solve this problem yourself. Okay. Pause the video, try to solve the problem yourself, and we'll see the solution later. Okay. Please pause it. All right. So I hope you paused the video and tried the problem and maybe got the solution also. Okay. So 10 students sit on 6 chairs such that one particular student is always seated on the first chair. Okay. Now what is happening is next day boss comes to the class. Okay. Here there are S1, S2 and S10. Okay. And let's say this is the boss. Boss comes to the class. He says, no, I want to sit always in the front seat. I want to sit in the first seat always. Doesn't matter where everyone else is sitting. Doesn't matter who is standing, who is sitting. I don't care. Okay. So I want to sit on the first chair and I want to sit always. Okay. So these are the two constraints. Now I've added a constraint on selection as well as on the arrangement. All right. I've added a constraint on the selection and arrangement. And now see what happens. Now I'm saying boss is always selected for the sitting. Okay, so remaining 9 people. Okay, from these remaining 9 people you have to select 5 more for total 6 chairs, right? 5 more. So what I'll do is 9C5. Okay, this 9C5 is the same constraint what we had in the last question. All right, now what happens is boss is saying I want to sit in the first chair. Okay, so let's say these are your 6 chairs. Now, boss said, I'll sit on this chair. So, boss, we placed boss on this chair. Now, remaining 5 students are there. Now, for other chairs, we have choices. Okay. So, for this chair, any 5 students can sit over here. Okay. Because boss is already seated over here, we will not count boss as a choice for the remaining chairs. Boss is not counted as a choice for remaining chairs. Okay, so 5 is seated over here. Now 1 will take place. Now 4 will remain. Similarly 3, 2 and 1. Okay, so for this case your answer is what? 9C5 into 5 factorial. These many ways are there in which your following constraint will be satisfied. All right. So I hope you got this solution as well. Let's move to another variation, I think. Yeah, okay, this is a big one, and I think this should be, yeah, okay. This is a big one, okay. So again, try to pause the video, okay, and try this question yourself. All right. So I hope you got the solution. Let's check out what this problem is saying. Okay. Make 10 students sit on 6 chairs. This is this such that one particular student is always seated on the first chair and another particular student is always seated on the either in the second last position or at the last position. Okay. So now what is happening is there is a uh, assistant to boss. Okay, let's call him assistant to boss. S1 and S2 are there. Okay, and then you have S10 people. Now let's say this is the boss guy. Okay, and this guy is assistant to boss. Okay, he wants to help boss in every action and all, and he wants to um have a reputation in class, let's say like that. Okay, so he's the assistant for the boss. Now assistant is saying, after boss sits in the first position, I want to sit either in the second last position or at the last position. I don't want to come in the front. Okay, so now with this constraint, what is happening is, see, I need to select S1 and S2 both now. Okay, I need to select both of them, only then I can make them sit, right? If I don't select them, how will they sit? Correct. So now that means these two are always selected for sitting. Okay, so now see, remaining 8 people will be there from S2 to S3. Okay, remaining 8 people will be there. So now out of 8, I need 4 more people. Okay, then only I'll have the count of 6 people now for 6 chairs. So I'll do this as 8C4. Okay, now once I do this, now my selection is over. With the constraint and all, selection is done. Next thing is, I'll try to arrange things. Now arrangement will be done in what manner? See, let me just take a different slide to explain arrangement. Okay, now we have 6 chairs. Let's call boss, the boss as B, boss is B, and A is the assistant. Okay, boss is B and A is the assistant. Now boss is saying, I'll occupy this chair only. We said, okay, you can take this. Okay, now assistant is saying, either occupy this chair or I'll occupy this chair, or I'll occupy this chair. So we'll make 2 cases. One case where the assistant is occupying this chair, or it can occupy this chair, right? So I'll add both the cases and I'll be done, right? So now remaining people are what? Remaining are 4 people. They are saying, we will sit anywhere we want, just give them a seat. Okay, so now this chair will have what? 4 choices. This chair will have 3, this chair will have 2, and this chair will have 1. Similarly, this will have 4, 3, and 2, and 1. Okay, so your A, the assistant guy, is either sitting here second last or sitting at last. So this is what? 4 factorial plus 4 factorial. So this gives you the answer as 4 factorial plus 4 factorial, which becomes 24, and 24 48. Okay, so there are 48 ways in which you can complete the arrangement. So we'll just go to the question. Yeah, this is it. So into, or you can say 2 into 4 factorial, or you can say just 48. Okay, because the assistant is saying, I need second last position or last position, always. Okay, so we'll first calculate in second last position how many arrangements can be done. Next, we'll try and calculate at last position how many arrangements can be done, and we add both the cases, and we have the answer for us. Okay, so if you see that this is how you can apply any method, and you can easily understand the question also and constraints also. Okay, so never do a mistake when you are trying to solve in this manner. So if I talk about fundamental counting principle, so that method is used mostly when digits questions are there. Okay, and we have a lot of digit questions in gate. So yeah, so next video what we are going to cover is some gate questions. Okay, and in which I'll use both the methods depending on which method is easier for the question. All right. Okay, so I hope everyone liked the video and you all are now a little comfortable in PNC. I will say, if you want to really get better in PNC, the only way is solve more and more problems, solve difficult, harder problems. That will give you more confidence for PNC topic. Okay. All right. Thank you everyone. So for watching the video, and if you like the video, please comment on that, like it, and don't forget to share and subscribe to our channel as well. All right, so I'll see you in the next part of the video. Thank you everyone.